Hello, and welcome back everyone to this series of videos where we're making a game in JavaScript without using any libraries or frameworks. So in the last episode, we added collision detection to the game, and our hero couldn't walk through the walls anymore, but he's still looking a little stiff. So in this episode, we're going to spice things up a bit by adding some animation to our game. To get things animated, let's think back to the very first episode of this series, where we downloaded a sprite sheet for our hero from opengameart.org. If we take a look at the sprite sheet, we can see that right now we are only using this image in the top left for our hero. But you can see the sprite sheet contains all the images we need to animate the character in several ways. Here on the top row, we have 4 images that we could use as the character's idle animation. On the next row, we have some images that we could use for a walking animation. And finally, on the bottom row, we have 3 images for the character's attack animation. So to animate the hero, you just need to keep track of the character's state. Are they idle, walking, or attacking? And then we just move through the animation frames at a reasonably fast rate. So let's do a little coding. First, you might notice that all the animation frames only face one direction. That's fine, since it turns out we can draw the frames to the canvas in reverse very easily, as you will see. Let's add a static property called directions that we will use as an enum. We'll just have 2 possible values, left and right. Now we add a direction property to the hero class and initialize it in the constructor. In the move function, we will update the state of the direction when the user presses the left or right arrow keys. Now let's turn our attention to the hero.draw method. What we want to do is draw the hero in reverse when the direction property is set to left. The way we can do this is by manipulating the game canvas context. First, we save the state of the context by calling the save method. Then we call the scale method on the context. This method can be used to scale in the x and y directions when drawing to the canvas. However, by giving a negative value, we can draw the image in reverse in either axis. So let's set the x value to -1. So now we are drawing backwards in the x-axis. Now we draw the image of our hero. However, there is one more trick here. When we are using a negative scaling ratio, the corresponding position and size values also need to be negative. So we multiply the x value by -1, and we do the same thing with the width. Finally, once we are done, we restore the game canvas to its old state, so we don't render everything else after this in reverse as well. So let's take a look at this in action. We can see the knight is now turning to face the direction it's moving. Nice. Now it's time to get animated. To start, let's make a little simplifying assumption that we will want to run through each animation once per second. So let's start by adding the following static property to the hero class. Each entry in the map will be one of the animations. For each animation, we need to know the number of frames in the animation and what row the images are on in the sprite sheet. And let's also create a property called current animation to keep track of the current animation for the hero. Now let's head down to the move method. At the top of the method, we will always set the current animation to idle. However, if the user is pressing any of the arrow keys, we will set the current animation to walk. Finally, let's go down to the draw method. First thing, let's go alter the method to take in delta time as a parameter. Remember from episode 2 that delta time is the time in milliseconds, since the last frame was rendered. This is important since we want to render the animations independent of the frame rate that we are rendering at, which we don't control. We will also add a property called animation timer to the hero class. This is a counter that we will add delta time to every time draw is called. When it goes above 1000, we will reset it to 0, i.e. we reset the timer once per second. Now we just need to take the timer and figure out which frame we should be showing in the current time. To do this, we just need to figure out how many milliseconds we want to show each frame for. So we take the number of milliseconds in a second, 1000, and divide by the number of frames in the animation. This gives us the number of milliseconds per frame. Take the animation timer and divide it by milliseconds per frame, and we get the index of the frame we want to render. Now we just multiply this by sprite width, and we get the x-coordinate we want to use to clip out of the sprite sheet. We then just need the row property from the animation, and we multiply that by the sprite height, and we also have the y value we want to clip. So let's try it out. And I think our hero looks a little more exciting with some idle and walk animations added. To finish things off, let's incorporate the attack animation into our game. This seems like it should be simple. In the hero.move method, let's check if the user is holding down the spacebar. If so, we will set the animation to attack. Let's see what that looks like. Our hero is lacking a little urgency in his attack. I think we need to speed things up. Earlier, we said each animation loop would always last 1 second. Let's change things up so some animations can go faster. Over in our animations enum, let's add a speed property. This property will indicate how many times per second the animation will loop. For attack, we will set the speed to 3, indicating we want to go through the whole animation loop 3 times per second. Now, down in hero.draw, we need to make some small modifications. To get the milliseconds per frame, instead of dividing the number of milliseconds in a second, 1000, by the number of frames in the animation, we instead divide it by the number of frames in the animation multiplied by the speed of the animation. Think of it this way. If there are 5 frames in the animation, and the speed is 3, meaning we want to loop through the animation 3 times per second, then we will be rendering 15 frames of animation per second. When we grab the frame index, we also need to modulate by the number of frames in the animation, so the animation loops. So let's try this out. Ah, that's more like it. Now he's really getting into it. Note that the way we've coded things also allows the knight to move and attack at the same time. Alright, so animation's looking good. I think this is a good time to wrap this video up. Don't forget to check out the source code, and don't forget to subscribe, because next time we're going to add some monsters to the game.